Alright, so for this video, we are going to figure out how do we find all 6 trig functions when we are told that we are given a point that falls on the terminal side of a given angle. Now this problem is very similar to a slightly different problem where you are told that you are given a point on the unit circle. If you are told you are given a point on the unit circle, that is something slightly different. I have a video for that you can look up, but this one is specifically when you're told that it is just a point on a terminal side. They do not say unit circle. If they said unit circle, what you're looking for is the point is actually on the edge of the unit circle here. That's not our situation. Our situation is, we're given an angle here. We're told the point lies on that ray, on that terminal side there that is created from that angle. So the point is somewhere off over here, not on the edge of the unit circle there. So in order to calculate the 6 trig functions based off of that, well, we need to know this distance first, right? So in order to find that distance, we need to use this formula here that is set to be solved for r. This formula just stems from the equation for a unit circle. So we need to first find r, and then we're going to take that r, and we're just going to input it into our relationships for our trig functions that we know. So first things first, we're going to need to calculate r, since we can see here, in order to find sine, cosine, tangent, secant, cosecant, cotangent, r is in every single, or in most of these stipulations. We need to find that first before we can do anything else. So finding r is equal to the square root of your x squared plus your y squared. That is going to come from the point that you are given here. We are told our point is negative 3, 5. So we are going to input that negative 3 for our x. We're going to input that 5 for our y. So that's just going to look like negative 3 squared plus 5 squared. And we just want to go ahead and simplify this. Well, negative 3 squared is a 9, 5 squared is a 25, and if we add these together, we get the square root of 34. Now, if your radical can be simplified, you do want to go ahead and simplify that. Square root of 34 cannot be simplified any further than that. And again, in most examples dealing with trig, you want to simplify radical, not the decimal that your calculator would give you. So r is equal to the square root of 34. I'm going to go ahead and add that in up here so that I have room to work our problems. So then in order to find sine, we are going to take y and just divide it by our r. So for our given example here, our y is a 5. Our r is the square root of 34. So it's just 5 over the square root of 34. Just keep in mind, anytime you have a radical in the denominator, you do need to rationalize the denominator. If you have a radical in the denominator, it is not considered simplified. You get rid of it by multiplying this whole fraction, top and bottom, by the square root of 34 in order to simplify it. Multiply across. 5 times the square root of 34 is just 5 times the square root of 34. And the square root of 34 times the square root of 34 is a 34, giving us 5 square roots of 34 over 34 for sine theta. Now, keep in mind, once we know sine theta, we can easily find cosecant theta, because cosecant theta is the inverse of sine theta. So take the 5 square root of 34 over 34, flip that around, and we get 34 over 5 square roots of 34. Simplify this, and that is what cosecant theta is equal to. Now, I'm old school. I like to simplify these by hand. If you type in 34 over 5 square roots of 34 into your scientific calculator, it should simplify that radical for you. Otherwise, again, keep in mind to simplify or to rationalize the denominator, multiply by the radical in the denominator, which means up top we have 34 times the square root of 34 over this 5 here. Square root of 34 times square root of 34 is a 34 that you drop down. And the 34 in the numerator cancels with the 34 in the denominator, leaving you a square root of 34 over 5 as our cosecant theta. So again, simplify it by hand or throw that into your calculator to reduce it. For cosine, it is x over r. So our x value here is a negative 3. Our r is the square root of 34, so very similar process as sine above here. So rationalize the denominator here in order to simplify this by multiplying by the square root of 34. Move that over in the denominator. Negative 3 times square root of 34 is negative 3 square root of 34 over a 34 in the denominator for your cosine. For secant of theta, we will take the inverse of that. We will flip that around, which gives us negative 34 over 3 square roots of 34. But once again, radical in the denominator, you need to rationalize that. Throw it in your calculator, simplify it by hand. For secant, we are going to be left with a negative square roots of 34 over 3 as our simplified radical for secant. For tangent theta, that is just our y over our x. Our y is a 5, our x is a negative 3, so we are left with a negative 5/3 for tangent, which means taking the inverse of that, just flipping that around, gives us a negative 3/5 for our cotangent. That is how you find all 6 trig functions on the terminal side of a given angle.